Hello everyone, my name is Jonathan Brum and I'm a forward deployed engineer here at FriendliAI. I wanted to take a few minutes to explore our dedicated endpoints together to help you and your team spin up models to exclusively host your workloads. Now, spinning up a dedicated endpoint and interacting with it is very straightforward and can be done directly from your FriendliAI portal. On the left-hand side, click on the option for dedicated endpoints, and you'll be taken to a page which lists any previously deployed models in case you wanted to wake a previously configured endpoint back up. Now, we'll get to how we wake up a terminated endpoint later on in this video, but let's start with creating one from scratch. So to do this, at the top right corner, you'll see a blue button which says New Endpoint. If you'll click to this, you'll be taken to a new endpoint configuration page. Now here at the top, we can give the endpoint a unique name. So let's say something like this. The way that you're going to refer to this endpoint in your code is going to be a little bit different, and we'll get to that in a moment as well. Now below this endpoint name, you'll see that we have a couple of different options where we can choose the model we want to use in this dedicated endpoint. Most commonly, you can select a model from a Hugging Face repo, or you can use a local artifact file that you have previously uploaded from some sort of local file you have on your machine. For this tutorial, I'll choose a model off of Hugging Face, and using this option gives you access to over 500,000 models that are as easy to set up as I'm going to show you here now. So you'll see here, once I click on this Hugging Face option, you're shown a search bar. Clicking into this will show you a couple suggestions for popular or trending models, or if you start searching for a model name, you'll see that the options that are given here also change below. For this tutorial, I do want to pick a model that will load somewhat quickly, so we're going to go with a very tiny 0.8 Quen model, something like this here. You'll see that once I have this model selected and it loads, I'll be shown below the available modalities for this model. So in particular, this specific Quen model can take input from text, image, and video, but the only output this model provides will be in text format. So below these model modalities, there are a few more advanced configurations that I won't dive into too much in this video, but I just want to quickly highlight the ability to add a custom chat template for this dedicated endpoint in case you want to directly affect how this model is going to respond, as well as if the model supports it, you can also include additional LoRa adapters on top of your base model. Below these options are some additional configurations for the endpoint. If you're not familiar with how these changes will affect your throughput or your workload, or how this endpoint is going to handle your traffic, feel free to reach out to the wonderful FriendliAI support team. We're always happy to answer questions to help your team best optimize how your endpoints are running. But really quickly, I just wanted to highlight you can control for certain models the quantization that the model is running at. Turning on this host KB cache, so we have caching turned on by default for all our models. What this option will do is actually extend that KB cache to utilize CPU resources in addition to utilizing the cache available on the GPUs themselves. So it essentially gives that endpoint additional buffer for caching workloads specifically, or caching tokens, I should say. After this, we also have the option to set up what's known as request queuing. So this will help you and your team control 429s, as well as just overall consistency in your throughput by controlling not only how many requests your replicas can handle before they start queuing requests or returning 429s, as well as how long a request will wait in a queue before it is errored out or timed out. Now, I wanted to briefly pause and dive into this configuration in a bit more detail, as we tend to get a few more questions regarding this configuration. Now, there are really two options that we're looking at to control request queuing here. One is the request count threshold. Now, what this is saying is how many requests can each of my replicas be processing simultaneously before it starts to queue up requests. We'll get to what replicas are a little bit later on in this video in a few minutes, but essentially this is the number per replica. So if I set this to 40 and I have only one replica running, then when that 41st process concurrent process comes into this endpoint, that 41st process will be queued until either the resources open up to process that request, or we hit the queue timeout, which we set here. If I had two replicas running and had this still set at 40, then I would be able to process 80 concurrent requests, and then on that 81st request coming in, that would then sit in the queue. Now, how long that request will sit in the queue is controlled by the second option here, the queue timeout. As it says below, if you want the request to essentially sit indefinitely until the resources open up, keep this as blank or as no limit as it shows here. Or if you do want to establish some sort of timeout, either for failover or however your workflows function,
You can set this in seconds, whatever works best for your team. So for instance, I can set this to 10 seconds. That means if I have an example with one replica running, I have 40 requests running concurrently in that endpoint. That 41st request comes in. It will sit now in a queue for up to 10 seconds. And then after 10 seconds, one of two things will happen. Either within that 10 seconds, one of the requests that we're processing will have finished, the resources open up, and that 41st request now fits in that window of 40, or those 40 requests have been running for all 10 seconds, so that request in the queue now returns with a 429 timeout error as indicated by this timeout. Now below these request queuing configurations, I just want to quickly touch on, we have some examples for speculative decoding. Now the model I'm choosing is quite small, so there's no options to turn on something to help with this decode step, but I wanted to quickly highlight that we have two options to choose for that decoding process. We can either use a smaller draft model that runs alongside your main model in the dedicated endpoint to help predict those tokens in that decode step, or you also have the option to control the n-grams that are returned per decode step. If you have any more specific questions, again, I don't want to take up too much time in this video, but feel free to reach out to either the FriendliAI support team, or there is always the option to check out our documentation above here, which we'll also get to later on in this video. All right, now for some more fun stuff and actually getting this model deployed. So below these endpoint configurations, you'll see we have first the options to choose which GPU that we want to deploy our model onto. Now again, I chose a very small model, so I have all these options available to deploy this 0.8 billion parameter model onto. However, if I had chosen something a bit bigger, let's choose an 80 billion parameter just to show here. Quen works as well, perfect. So you'll see here, once this model loads, if I come back here, that option for a singular A100 GPU is now no longer available, because that singular GPU does not have the resources available to deploy this larger model. I could potentially deploy this on a 4x A100 deployment, or again, I can choose something different. Maybe I want to use a 2x B200 deployment because I want that additional compute power that's from the B200 chip as opposed to a smaller A100 chip. One additional note as well is you'll see the GPU cost per hour next to each one of these potential configurations for the GPUs. So you'll see here, per replica, if I chose this first option, then my replicas would cost $2.9 an hour to use just one A100. If I wanted to, again, if I want some additional compute or what have you, I could choose something like an H100. In that case, the singular GPU of H100 would be billed at $3.9 an hour per replica. So if I had two replicas of this 1x H100 configuration running, that would be consuming in total two H100s and therefore be billed at $7.8 an hour in that case. Now, speaking of replica count, let's talk about that below here using our auto-scaling configuration. Now, you do not need to use auto-scaling if, for instance, you want to just set one replica and have it running consistently with either a consistent workflow, or you just don't really have anything that would require auto-scaling. You can set the number of replicas to run consistently here, or if you do decide to use auto-scaling, we have a few different options which we'll dive into. So if you do choose to use auto-scaling, you'll see we have a few different options for the type of auto-scaling that you can configure for this endpoint. There is the default algorithm, which we recommend to use if you're not quite sure how your auto-scaling is going to look, or if you haven't configured this before. Or we also have the option to control this by request count. So the way this request count threshold works is as it's mentioned here in the tooltip below, and it adds the number of current requests being processed with the current number of requests currently waiting in queue, divides this total by 4, and then compares that total to this threshold here. So you'll see if I kept this threshold at 10, then 40 concurrent requests can either be actively being processed and or in queue before any additional auto-scaling is considered for this endpoint. If I set this to 12 instead, then that threshold for auto-scaling now becomes 48. After 48 concurrent requests either being processed and or in queue, then that 49th request will then spin up that next replica up to your max replica count, which is set down here. So below, once we set what type of auto-scaling we are using, we can set up our min replica count and our max replica count. So the way these min-max replica configurations work are in conjunction with the auto-scaling type that we've selected above, as well as our cooldown period below. What the min replica count configuration is telling us is after this cooldown period, what is the minimum GPU count that my endpoint will reduce down to. So for example, in this configuration, if I have one replica running on an endpoint and I don't send any requests to that endpoint for 300 seconds, that single replica will spin down to 0, as that is my min replica count here. If you don't ever want to run into a situation where you have to essentially wake up an endpoint because it has spun down to 0 replicas, you can always set that min replica count to 1 or a higher number if you want to say have at least two replicas running of your endpoint at all times. Conversely, you can also change this max replica count, and this will tell you the maximum number of GPU deployments or replicas for this endpoint that will be deployed based on your auto-scaling type and your thresholds above here. Max replica count at 0 and 1. We're not doing anything too crazy for this example, and I'll also keep the default cooldown period of 300 seconds. Below these auto-scaling configurations, you'll see some options for configuring the engine itself. I would keep these to the default settings as well if you're not quite certain what these are changing, but again, feel free to reach out to the Friendly support team for any specific questions on what this is going to be changing. And finally, at the bottom, you can enter any comments about your deployments here. So when these settings look good, go ahead and hit deploy here at the bottom, and you'll see that this endpoint will start to initialize here for us. At the top, it will say initializing and give me a percentage telling me how far along that deployment has completed. While this is deploying for us as well, I just wanted to highlight a few things here on this dedicated endpoint overview page. First and foremost to highlight is the endpoint URL we'll be using is this dedicated endpoint. So if you're used to using the model APIs, for instance, you might be used to seeing serverless here at the end. So just highlighting or make a note that we're using the dedicated endpoint for these calls to this endpoint, as well as for the model, we're going to be using this endpoint ID instead of the model string you might be used to again for the model APIs. You also see on the right a timeline of version histories for this dedicated endpoint. Now, this is the very first time we're creating this particular one, so it is v0, but if there were future iterations where we're redeploying this or making changes, you would see a timeline indicating when those changes were made and by who, as you see here. You'll also notice as I scroll down that these settings here, once the model is loaded, will reflect the settings that we configured when we set up this dedicated endpoint initially. As well as at the bottom, you'll see an overview about the instance type that we're using for the GPUs, what our auto-scaling looks like, and at the bottom, once this endpoint is finally running, you'll see what that hourly rate currently looks like. So if we had multiple replicas, this will show us what that hourly rate in total is looking like, as well as on the left-hand side here, what is the total lifetime cost that this endpoint has incurred over all of its deployments, over all its replicas, just like what is the total amount that this endpoint used in resources. Awesome, and you'll see here once that endpoint is ready to go, that yellow initializing status has changed to green running, as well as my endpoint health is showing healthy. Next to that, it shows that I have 1 out of 1 active replicas running. Again, my min-max replica count is 0 and 1. If I had set my max replicas to 2, for instance, this would say potentially 1 running out of 2. This tells me how many total GPUs I have running across all my replicas, as well as what that current deployment across all my replicas is being built at. So once this endpoint is healthy and running, you'll notice that interacting with this model is just as straightforward as our model API experience. So definitely go check out that quick start video if you haven't already. But the same thing we did over there is we're going to first check out this playground tab. And what this is going to give us is a chat interface to help us start working directly with our model immediately. So I can start interacting with this model here. Now, if you'll remember originally, when I set up this model, there were additional modalities outside of text as well. So not only can we interact with it as the model API is using text, but I can also do things like upload images and ask it to describe the image here. And you'll see here, it is taking in those additional modalities and reacting to it separately than how certain models in the model APIs would be able to handle that multimodality. Now, if I wanted to, I can come up here to the corner, same as before, and use this view code button to take this exact UI conversation and back and forth and paste it into my IDE for either Python, JavaScript, or curl. Now, we'll get to that in a second, but I also wanted to highlight just how easy it is to switch over to using your new dedicated endpoint, especially if you're used to already using something like the model APIs. So to switch over to start using this dedicated endpoint, we're going to need these 2 pieces of information that I highlighted here at the top of the overview page previously, which was the endpoint URL and the endpoint ID. we're going to head over to my PyCharm IDE, where if you have already seen the Model API Quick Start video, this script might look familiar. But essentially, this is a quick call going to right now the DeepSeek model that was scoring a previous conversation we had in the UI. But again, I wanted to show how easy it is to switch over from using a workflow originally pointing to our model APIs to now use that same thing on our dedicated endpoint. So again, all we're going to do is switch over this URL from being serverless to being dedicated. And then down here for the model, instead of using the model string, we're going to refer to our endpoint ID here. And that's it. All those are the only two edits we need to make. And now this exact request will go to our dedicated endpoint and return our response here instead of going to the DeepSeek model. I also wanted to show how easy it is to bring an existing conversation within the UI into your IDE or into your existing code workflows, similar to the Model API experience. So same as before, we're going to go into the playground here. We're going to give the model a prompt. Now, rather than hitting enter and sending this into the UI directly, we're going to instead hit view code. You'll notice that I have that same user prompt here in the request automatically. We're going to go and instead of using Python, let's use a curl request just to show a different IDE in this video. Real quick to note, as always, is I have my API key stored as an environment variable. So that's why I can quickly copy and paste directly from the UI here. If you do not have this stored, you have to update this line here to accurately refer to your API key, either it being hard-coded or however you have it stored as a different environment name. But again, I have mine named as API key as well, so I can quickly copy and paste this and bring this into my terminal. One other quick thing to note here is that this is showing me that the default settings for this request is going to be a stream true option, which will stream back all the responses token by token. I'd rather see this response come back all in one chunk, so I'm going to update these stream options here by erasing them. And instead of saying stream true here, we're going to say stream false. And this will give us the response back from the model, which we'll read back here in a second. So before we go back and read our goodbye from our model, I did want to highlight a few more things here in our UI. Importantly, next to our playground tab and similar to our model APIs, we have an option to view metrics for this dedicated endpoint. So same as before, we can see this broken down to the processed request, the processed tokens, as well as some latency feedback or latency metrics from time to first token, time per output token, and overall request latency. At the bottom here, we can also see the amount of replicas that have been spun up over time for this endpoint. So you'll see here, I've only had the one spun up because that was my auto-scaling. But you would, again, if you had something that was a bit more volatile, you would see how this would be changing due to your workloads changing as well. You can also see the associated cost for these endpoints. I'll try to get an example from a previous endpoint to show this a bit more, but since this is, again, a newer model, I don't have too much data going through it, so you're not going to see much here. Same as you would for a brand new endpoint that you started as well. A lot of these metrics will be just starting to come in. So you'll see here for overall traffic, this a few came in here. I got a few 400s, a few user error, but mostly 200s coming in for this dedicated endpoint. And at the bottom here, you actually can see specifically what your requests were breaking down to for status codes, your token breakdown, as well as your latency throughput. And finally, next here on the versions tab, we essentially have an expanded view to what we saw on that sidebar that, again, goes over all the notes and version histories for your endpoint. So you can, again, see comments made by your colleagues, who made what version, when it was updated, and by whom. But you can see a more expanded view of those notes and version histories here in that version tab. And finally, let's touch on how to wake up a previous dedicated endpoint after it has either been shut down manually or it has been shut down after an elongated cooldown period and you have something like 0 min replica count. So to do this, we're going to, on the left-hand side, click again on dedicated endpoints, where again, we see all the names for the models for all the endpoints that we have access to based on our team. So we can either look for the name here by clicking on it, or we can search for names as well to find any previous endpoint that we might have created. And then once we find the one that we're looking for, let's grab this one here. We can click on the model to open up that same dedicated overview page. And once this loads at the top, you'll see an option to wake the model. So you can see here, the endpoint is in a terminated state. It is not available for endpoint health. There are no active replicas or GPUs in use, and it is not currently billing me anything. If I want to change that, all I have to do is hit this restart button here at the top, and this that's all it takes. This endpoint will take a few minutes to spin back up. You'll notice this is the same initializing status we saw before, and we'll give this a few minutes to start back up for us as well here. All right, and same as before, you'll see that this endpoint is now running. I have a healthy endpoint with 1 out of 1 replicas running. There's 1 GPU in use, and this is how much this current endpoint is costing me. Also note that at the top here, you have an option to manually terminate this endpoint. So if I click here, you'll notice that this will confirm that I want to terminate to begin with. But if I do want to end my endpoint here, you'll notice that this will go from running to a terminated status as it was before. If we wanted to restart it again, we can click it here. Now, one other option I also wanted to mention was this update option. If you ever need to change how this endpoint is configured, you can click into this, and this will bring you back to a similar page as when you were initially setting up this endpoint, and you can change any of these configurations if you were able to in the past. The only exception to this is that you cannot change the instance type. So if this model was deployed initially on an H100 and your team decides, oh, you know what, we need the additional compute power of a B200 for this deployment instead, you wouldn't be able to update that exact endpoint. You would need to create a new endpoint, and when you were configuring that endpoint, choose the B200 GPU instance type in that endpoint. But other than that, you have the options to change your auto-scaling. You can change how the auto-scaling is using either the default or the request count, the engine configuration. Again, anything other than the GPU architecture, you have the option to update for these endpoints on the fly. All right, and with that, I think it's time to bring this to a close. So let's go back to our model and see what kind of goodbye speech it wrote for us earlier. Let's see here. It says, thanks for being here and enjoying event. I should have given it an event name. We had a fantastic time, indeed we did. I hope you all had a wonderful day. Let's catch up and hit me up for coffee. It says over the weekend, but honestly, feel free to hit us up for coffee or come by to visit the FriendliAI offices anytime. If you have any questions, please do not hesitate to reach out. Either myself or my colleagues from FriendliAI support are always happy to answer any questions to help you and your team excel or optimize their workflows. Looking forward to working with you and your team, and I look forward to seeing you all in the next video.